Herman, you should be broadcasting now. Yeah, just stay right there and you're good to go.
Okay.
And thank you everybody for coming on out to the final presentation. I'm very happy to introduce Herman Suarez. Herman is a serial entrepreneur and has launched multiple products that are in the market now, and is going to tell some stories about product development. So thank you so much, and Herman, it's off to you. And I'll go ahead and mute myself, and you can share your screen.
Okay, Danny, thank you very much for the introduction and the opportunity to be part of the event. Thank you, everybody that is joining us. Now I'm happy that I'm gonna be sharing some experience, my experience in the process of developing products from prototypes to scalable products. So let me share my screen now. Screen, this one. Okay. Okay. So first, I'm gonna give a small introduction from myself. I'm a telecommunications engineer. Also, I have a master's degree in business administration. I'm originally from Venezuela, but I've been living in Colombia for 10 years now. And I've been an entrepreneur since 2014 when we started Cento, Electronics Scaling Hub, which is a one-stop shop for IoT products and electronic products, where we help you uh, develop the products in different stages. Um, since then I've been the CEO and CTO of the startup, and I've been working in the IT industry for more than 16 years now. First as part of companies that provided services related to infrastructure and networking, and then since I don't know, 2012, I've been very involved with IoT technologies. And I would say I'm not an expert, but I'm very passionate about the technology, IoT, and how innovation can make a better world every day, every new day. And so I think I'm I, I hope that the experience I'm going to share will help you in your different projects. Um, I'm going to talk about two cases, two products that we developed. One is the Smart Weight, which is an automatic poultry scale. What is that? It's a scale that we place on inside the farms, the chicken farms, the poultry farms, and it will start measuring the weight of the birds once they get on the scale by themselves, and it's able to calculate an average weight of the flock of birds in a daily basis. The other product is the Peak Vision, which is a camera-based product that is used to estimate the average weight of the pigs inside a pen, also in a daily basis. So we place this this device on the top of the ceiling, and it will start taking pictures from the pigs below. And with image processing and machine learning, it will estimate the weights of the animals. So these products are very important because currently the weighting in the farms is done manually. So imagine weighing a pig of 300 pounds. It's really, really difficult. Making a pig that size move and go through a mechanical weight is really hard. You will need three guys to do that. Uh, and the same happens in poultry farms. You will find 20,000, 30,000 birds inside a house. So in order to have accurate estimation of the average weight of the animals, you will have to gather a lot of birds. at least 200, 300. So that will take a lot of work. So this with this solution, you will have more reliable measurements in a daily basis, and without labor. So uh, yeah, so this is what these solutions do. Uh, and yeah, I'm gonna start talking about how did we start. So we were working with a multinational that is focused on animal nutrition. So they knew very well the market, the industry, and they detected the need. They were very clear about the lack of weightings in the farms, and what is the effect on that. A lot of inefficiencies on the farms, a lot of um, uh, problems in quality. So we decided to attack uh, this problem in a new way with the pigs, with the image processing, and with the birds, we had the challenge that with image processing, it's really hard to do this because the feathers of the birds are not very uniform. So it can change between each individual. So we had to find another way, and then we went like with the traditional approach with a mechanical solution. At the first stage, we didn't think about communication. We didn't think about the look of the device. We didn't think about how we were going to fix it in case any problem. We just needed to validate we just need to validate a hypothesis about uh, what we wanted to gather. Um, so what we did, the first thing we needed to do was to go to the farm, spend a week, 2 weeks there, live inside the house, understand how the pigs behave, understand how the chickens behave. They are very curious. They are moving all day. They are moving around all day. They start fighting. They start running. So they get together in big numbers. So how that would impact the mechanism that we decided to implement. So it was very funny because at this moment the lifespan of the prototype was like 8 hours. Once we tested in the farm, then it was already broken. So it was very hard. Working in the farms is really hard because the conditions, there is a lot of dust, humidity, gas concentrations like ammonia. Um, they are kept very warm because of the animals. So it was very challenging. But at this moment, we didn't think about anything of the how will it look. Just make it work. And we have many funny stories about these moments in the project. Another thing that we do while we were doing the early prototypes was learn from others. So at that moment, there weren't a lot of technologies available to do like remote monitoring, like now. So we investigated. We found a technology in Europe. We found another technology in the U.S. We bought the devices from those companies. We installed them, and we learn a lot from them, and we learn faster. So, for example, we knew that the communications in the farms is very poor. It's very unstable. So some of those devices weren't working very well in those conditions. They lost connection, and we had to go and turn them and restart them. Also, the power supply on those farms was very poor. And you will get, like here in Colombia, you will get a lot of electrical storms, so they will get broken really easy. So we learn from them, and learn faster. So my message here is don't reinvent the wheel. Go find out what's there available in the market, learn from them, and 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 improve your design from using those learnings. At that moment, we got like in the first prototypes we said, hey, this could work. We are gathering information that if we start processing it well, or if we improve the way we gather that information, we think it's going to be very useful. So then we started to develop the what we call the first generation of devices, which were we needed them to transmit to the cloud. So we would monitor from remotely the we would gather the information remotely to start processing it and understand it. But we didn't think at this point about user experience, about support, about deployment. So that let us go faster at till some point. I'm gonna explain to you a little bit more about that. And the what I mean is that if you start thinking about many things about the operation, then you will delay this development process at the beginning. So uh, we start deploying fast, but at some point when we had bigger numbers, it became very expensive because we had a failure rate of 30% in the first month of installation. That was incredibly high, but we needed it to we needed to validate it very quick. So what we did an assembly, or we didn't produce the devices in big scales. We produce 10, 20 devices maximum, and then ship them to the farms, and then gather back some devices with problems and learn from them, and then in the next batch of 10 or 20 devices we will improve. We will do more. We will implement improvements like, I don't know, like improvements to avoid this. This is what we were getting in the first generation of devices. Scales full of dirt, full of humidity, uh, with worms, with bugs. And the outlets were also full of dirt. So um, it was a very challenging environment, and we had to work on a lot. Especially the smart weight was mechanically was very challenging because it was in direct contact with the animals. The ground in the farms is very dirty and humid. But at the same time, we're having this kind of information, a curve of weight, of daily weight of the birds inside a house that will help the producer detect anomalies in the house, in the pen, in the barn, with more opportunity, quicker, and will also give them um, the ability to forecast the weight in the coming weeks or days. So they will be able to plan their production. So we had challenges, but at the same time we had promising results. So this first generation of devices, we deployed hundreds, and at some point we said, hey, if we continue as we go, this will be crazy. We are creating a snowball here. So if we don't wait, if you don't stop and think about a scalable product now, then it's going to be a nightmare in the future. So this is when we started designing the scalable product. And one thing that we didn't did in the first generation devices that we did in this scalable product was that we got help. At the beginning, we wanted to do everything by ourselves. So we designed the mechanical part, working with a couple of designers, and we did all the electronic design without a lot of knowledge. But here we got a lot of help from the electronic design, from the firmware design, from the mechanical, from compliance uh, um, aspects. So we knew that it was getting complex, and if we wanted to make a scalable product, then we will have to get help to make something very good. Um, and here we thought about the things we didn't think before. So how are we going to support to provide the support, the maintenance? How's going to be the user experience? And for example, the scale needs to be calibrated. How are we going to calibrate it? So those kind of things that uh, every time we had to calibrate the scale in the earlier stage, we had to go to their farms. So imagine here going to a farm, um, going to a farm that is like 3 hours away just to calibrate something, just to change batteries. It was becoming a nightmare. So we had to think about the operation and the user experience at this stage. Uh, we got all the help. We developed all the electronics as we with all the learnings we had from the previous stages. And one thing that uh, happened a lot is the as I said, the mechanical design from the scale is very challenging. Things like in the paper, we say, I don't know if in English is the same uh, uh, expression, but we said that papers resist everything. Like you can draw everything on paper and it will work. But when you go and prototype, when you go and to the 3D printer and do it, it, it probably won't work. So, for example, we deploy hundreds of scales without this handheld. No, this this piece here to hold the scale. And what we were getting was a lot of problems in the scale because it was very heavy, and people in their farms were grabbing the scale with the cable, and the cable was getting broken, and we had to develop something to we didn't think about how to hold the scale at the moment. So you have to think about how the people is going to interact with the product. It's very important, and make sure you have plan. You will have to iterate a lot during mechanical design. Certifications, something new for us at that moment also. But at this moment, you have to, it's really important to keep in mind all the compliance and the certifications in development process. Because, for example, an FCC certification could could go from $3,000 to 70,000 if you don't use the correct components in your design. So make sure you use pre-certified components, and you have to make sure what kind of uh, transmitters are you using, and if you are combining technologies that in your device. Every time you make it more complex, it will be more complex to support it. It will be more complex to certify, and it will come with more cost. So when we had like already the scalable product that we dream of, and it was ready and it was working, we said, okay, where are we going to produce it? We had like a very manual assembly process at that moment, and we said, hey, if we have a very cool product, but if we keep producing it in the way we are doing now, we're not gonna reach the quality levels that we think that we want. So we went to San Francisco, to the Bay Area, visit some factories. We went to China, to Shenzhen, and visit different factories. We went to India, also to the Bangalore area, um, and talked to many people and learn a lot from them. And we found out that if you're going to produce an electronic board, there are plenty of places that you can do it with a really good quality, and any quantity that you need, from 5 boards till many thousands. But if you're gonna do the whole assembly of the product, then you will need to place orders of 5,000 at least to get company set up an assembly line for that. And we said that's not what we need. We needed flexibility. We knew we had a product, but we knew it will require improvements, continuous improvements, and we would find books and problems. So we couldn't produce 5,000 units and of a smart weight and then find out that it will have a problem on the cable. We were still testing, exploring the market. We were developing different markets in different countries. So we couldn't order 5,000, and we were starting doing deployments in the U.S. And we needed a continuous feedback between a communication between the production and the development, because the development was like working on improvements while the production would happen. So we needed like a very simple and direct communication between those processes, and we needed cash flow. We couldn't invest $1 million in an order while we needed to invest money in marketing and software development and different integrations. So we needed to have a more smaller batches. So what we did, we came, we developed our assembly capability. Uh, we did what we call a one-stop electronics scaling hub, and that's what is Cento today. It's a one-stop shop where we can help you develop, prototype, develop, scale, and mass produce your electronics. Uh, we've been through all this process. We know the challenges. We've been a startup. We are not a contractor. We are in a startup, and so we know the challenges that you will have from the commercial aspect, from the supply chain aspect. So we want to share this knowledge, and we want to help other companies from what we learned so far. Um, we have deployed more than 30,000 IoT products since we started. Sorry, more than 15,000 devices since we started. Um, we have developed 30 IoT products, mostly for industrial IoT applications, and we have deployed in 15 different countries, including USA, Latin America, and Europe, and Asia. So also that's very important. For example, when you're going to work with different countries, make sure you have a platform that is open and universal to adjust, to make adjustments, like to to be able to comply with the restrictions from telecommunications or electricity. So yeah, that's what we do in Cento. We want companies, startups with electronic products grow and be able to massify their products, and we want to help them in that process. Uh, some final thoughts about what we learned so far is that a prototype is not a product. A prototype is 30% of the product. Where I want to go with this is when we were estimating the investment that we had to do at that moment, we weren't even close of how much money we were going to need in order to have an scalable product, because we were thinking just in the prototype. And there's like a fake illusion now, like in the in the world, that if you can develop something from an Arduino or a Raspberry Pi, then you already have a product. And I'm not saying I don't want to be like negative in this way, but you have to be naive to start a project like this. Otherwise, you won't start. If you start thinking of what you have to do since the beginning, you will never start. But be aware that the investment to develop an electronic product and a scalable electronic product is much bigger than having a prototype. Get as much help as you can. It will save you money and time, mostly time. Um, it's very important. You have to go fast. So we've been we've been uh, we fail in this at some points in the development process, but and what I found out is that whenever we got help, we will move faster. We will learn in the process, which is very important. And when going big, simplicity is your best friend. If you if you start thinking about many features, about many things you wanna do with your device, then it's gonna get more complex to support, to develop, to maintain. Uh, in order to get the certifications that you will need to sell it in any country. If you have a complex product, then it will need more investment, and it will be hard to. It will require more energy to maintain in the future. And it's not about the idea; it's about how you implement it. So, um, for this last thought is kind of the same of the first one. Get help, because uh, when you add the complexity of the supply chain, of the cash flow, of uh, the compliance, uh, you have to it gets very complex. So you have to get help from to make sure it goes as smooth as possible. Every day you can save and learn from others. It's a lot of money, and in this kind of industry where everything goes fast, I think the opportunity cost is the biggest one. So yeah, that's basically where some of the thoughts, some of the learnings we have during this process, and that's how we want to help you live if you give us the opportunity to work with you and help you scale and massify your electronic products so you can focus on growing your business. Thanks.
Thank you so much, Herman. That was amazing to see, and I don't know, I just have to say that that picture with the chicken on the scale just made me like happy. It was awesome to see that. So, yeah, thank you so much for sharing your story of growing these two products that are in the market and then building up the 30 plus products that you have now through Cento Tech. So, um, all right. Thank you very much. And everyone, please go ahead and feel free to visit Herman and Water at their booth down in the center of the exhibition edge, the one with the US and Colombian flags.
Yeah.
Check it out.